Question 12, Part C. J is making a pattern using triangular tiles. The pattern has 3 tiles in the first row, 5 tiles in the second row, and each successive row has 2 more tiles than the previous row. Part 1. How many tiles would J use in row 20? Express the pattern as an arithmetic series. Now, row 1 has 3 tiles, row 2 has 5 tiles, row 3 has 7 tiles, and so on. So the series will be 3 plus 5 plus 7, and so on. So we can see that the first term, A, is 3, and the common difference, D, is 2. So that's the difference between any two successive terms. So using the formula, Tn equals A plus n minus 1 in brackets times D, where A equals 3, D equals 2, and n equals 20, since the question is asking for the number of tiles used in the 20th row, we have T20 is equal to 3 plus 20 minus 1 in brackets times 2, which equals 41. Therefore, 41 tiles are used in row 20. Part 2. How many tiles would J use altogether to make the first 20 rows? Using the sum formula, Sn equals n over 2 outside of A plus L, where A represents the first term of the series, L represents the last term of the portion of the series that we're adding together, and n is the number of terms in total in that portion of the series. So in this case, A equals 3, L equals 41 that we found in part 1, and n is equal to 20, since we're interested in the sum of the first 20 terms of this arithmetic series. So S20 is equal to 20 over 2 outside of 3 plus 41 in brackets. So that's going to be 10 times 44, which equals 440. Therefore, 440 tiles are used to make the first 20 rows. Part 3. J has only 200 tiles. How many complete rows of the pattern can J make? Using the alternative sum formula, Sn is equal to n over 2 outside of 2a plus n minus 1 in brackets d, all in brackets, we need to solve for n the equation 200 equals n over 2 outside of 2 times 3 plus n minus 1 in brackets times 2, all in brackets. And if you recall, A is equal to 3, so that represents the first term of the arithmetic series, and the common difference is 2. So simplifying what's in the brackets here, we get 200 is equal to n over 2 times 6 plus 2n minus 2. Combining the like terms here and here, so 6 minus 2 gives us 4, and multiplying both sides of the equation by 2, we get 400 is equal to n outside of 2n plus 4. Expanding the brackets here, we get 400 is equal to 2n squared plus 4n. Dividing both sides of the equation by 2, so this 400 becomes 200, and then moving that over to the other side so it becomes negative 200, we form a monic quadratic equation, n squared plus 2n minus 200 equals 0. So solving for n using the quadratic formula, we get n is equal to negative 2 plus or minus the square root of 2 squared plus 4 times 1 times 200 all over 2. Noting that n needs to be positive, since n represents the number of rows that can be completed. So considering the positive answer for n only, n is equal to 13.177 and so on, which we can interpret as 13 complete rows, plus part of the 14th row. Therefore, J can make 13 complete rows with 200 tiles.